Right, in today's video, we're going to do two problem sums that require us to construct perpendicular bisector, angle bisector, and also to do some shadings. But before that, I think we can work on some basic concepts, like what does perpendicular bisector means, what does angle bisector means, and some other necessary concepts that they are required to help us solve problem sums involving geometrical constructions. Right, so first of all, let's understand what does perpendicular bisector of a line segment mean. So that's start off by having 2 points. That's 2 points, point A, point B. Supposing you station at point A, and then you have a friend that's stationed at point B. And also supposing that you have a third friend that's called it person C, and you want your friend to be standing in such a way that he must be equal distance from you and also equal distance from point B, from friend B. We should not call your friend point, from friend B. Right, so where do you think your friend C can stand? Right, so one possible position would be this. Another one could be this. It can be this. It can be this, right? So let's observe all these different positions of your friend C. So you can see that we can actually draw, I can actually draw a vertical line that passes through all these different positions, right? So what happens if I draw a line that passes through all these different positions? Yes, you can see that actually this line that we have drawn, it's the perpendicular bisector of a line segment AB. Right, and in fact, here this is the midpoint of your line segment. This point here is actually the midpoint of AB. Right. So therefore, if the question says that you need to draw a line segment that is equal distance from point A and B, then what they're referring to is you need to draw the perpendicular bisector of the line segment that join the 2 points. Okay, so in summary, when you're equal distance from point A and B, it means that you can be anywhere on the perpendicular bisector of a line segment AB. Right, the next thing is that let's look at what does angle bisector of an angle mean. Right, so let's start off by having an angle ABC. Okay, again, let's imagine that you need to be standing such that you are equal distance from the line segment AB, also equal distance from the line segment BC. So where do you think you should be standing? Yes, so one possible position would be this, right? That means in the middle, right in the middle. Another possible position would be this. And another one will be this. So likewise, if I were to draw a horizontal line that passes through all these different positions and also touching point B, you will see that what we are getting is actually the angle bisector of this angle ABC. Right. So sometimes when the question says that you need to draw a line segment such that you're equal distance from another line segment AB and BC, that means you are actually equal distance from 2 line segments. Okay, 2 line segments. Then what they're referring to is the angle bisector. Okay, right. So in this case here, how do you know where to put the tip of your compass? So you usually put it at the middle letter. So if you need to find the angle bisector of angle ABC, then you place the tip of your compass at point B. If you need to find the angle bisector of DEF, let's say, then you put the tip of your compass at point E. Right, so the third concept involving geometrical constructions would be, sometimes the questions will say that you need to be at a certain distance from a certain point. Like let's say for example, you need to be 5 cm from point A. So let's start off by having a point A, and then if you're 5 cm, if your friend is 5 cm from you, so one possible position will be like that, right? But it can also be, your friend can also be standing at this position, right? Point B here. It can also be, as long as he or she is 5 centimeter from you, right? It's another possible positions will be like this, right? Just basically around you, right? Do you agree? Basically around you. So if I'm going to join all these different positions, all these different positions, what do you think is the shape that I will get? Correct, you will get a circle. All right. So therefore, when you are at a certain distance, let's say we call the distance x unit from a point A, from any point, just a point, it means that you can be anywhere on the circumference. You can be anywhere on the circumference, okay? Anywhere on the circumference of the circle with the center A and radius x unit. So it can be 5 cm as demonstrated here, or 7 cm or 8 cm. Right, in this video, I'm going to show you how we can draw a perpendicular bisector. All right. So to draw a perpendicular bisector, basically I need to draw a line segment of any length will do. Let's say I want to draw a perpendicular bisector of this line segment that it's 9 units. 1, 2, 3, yeah, 9 units. All right. Okay. So if you look at this line segment, I'm going to call this the two endpoints. Okay, the first point is point A. The other endpoint is point B. All right, so I'm going to use a compass to draw the perpendicular bisector. All right, so this is an online compass. So, but I think it kind of looks the same as the compass that you have. Okay, how much? Okay, the thing is that we need to draw two arcs. Okay, need to draw two arcs, and these two arcs will intersect at two intersection points, and your perpendicular bisector will pass through these two intersection points. So the thing to the first thing is that how much do I, how much do I open up this your compass, right? So I'm going to show you. Supposing you just, okay, wait. If you look at your compass, place the tip of your compass at point B. Place it at point B. All right. Supposing you just use this length. Okay, I'm going to fix it. Right, and then let's draw a arc. Okay. After you're done it already, bring your compass to the other side, to the other point, and then don't change the length, fix the length, and then draw another arc. All right, you see that these two arcs does not intersect each other, right? Yeah. So you can't actually draw a perpendicular bisector. So therefore, the length of your compass, the how much to choose is very important. Okay, so how much to choose? You need to make sure that the size of how much you can open up your compass, all right, has to be more than half the size of AB. So half of AB is somewhere here, so it has to be more than that. Okay, so now I'm going to fix the length already. Okay, so I'm going to draw a arc. All right, after you've done that, bring your compass. Okay, put the tip of your compass at point B, then draw another arc. All right, so you can see that these two arcs will intersect at this first point here and also the second point here, right? There are two intersection points, right? Then use a ruler, all right, and then draw a line that cuts through this two intersection point. Okay, so this line that you have just drawn is the perpendicular bisector of your line segment AB. Why is it called perpendicular? Because this angle here is 90. Let's try to measure it, and Yes, okay, and yeah, it's not exactly, yeah, it's 90. All right, 90. So therefore, that's the reason why it's called perpendicular, because this angle here is 90. And if you're going to measure the distance, all right, from A to the, you see that from A to the midpoint here, this is the midpoint here, is 4.5. And then also from the midpoint to B is 4.5. So therefore, the distance, this distance here, okay, is the same as this distance here, right? So this point here, right, is actually the midpoint of your line segment AB. Okay, so this is how you can draw a perpendicular bisector. Right. In this video, I'm going to show you how to do a angle bisector. Now, this cool interactive tools that I'm using, it's from mathpad.co.uk. All right, it's a freeware. You can just use it online. Okay, it's really very cool. All right, so let's draw a angle. Any size will do. So I'm going to show you how to draw a angle that is, let's say, 80 degrees. Okay, so I'm going to place it here. Right, so 80 degrees will be, yeah, this point here, right? $80 is there. Okay, I want to make a mark there. Okay, make it smaller. All right, so 80 will be here. Okay, make a mark there. Right, and then use a ruler, join. Okay, join to the point there. Right, so I'm going to call this angle A, B, C. So what I'm going to do is I'm going to divide this angle ABC, which is 80 degrees, into two equal half. So 80 degrees divided into two equal half, that means it will be 40 and 40, right? 40 and 40. So let's say later, let's see later on whether we can have 40, 40. All right, so to draw the angle bisector of this angle ABC, right, where do I put the tip of your compass? Do I put it at point A, point B, or point C? Okay, so it's very easy to remember. If you look at this angle ABC, the middle letter is the letter B. So you just place the tip of your compass at the middle letter, always at the middle letter. So let's say if you want to bisect angle DEF, you just place it at the letter E. Okay, so here I'm going to place it here. So the next question some of you will be asking is that how big, do I need to draw the arc? It doesn't matter, but don't be so small. Don't be so small until you can't really see. So a reasonable size will do. You don't really have to be half of the length AB, unlike your perpendicular bisector, it's not necessary. But the reasonable size will do. And then once you have decided it, and then just fix the length. All right, and then we're going to draw an arc like that. Okay, right. Okay, after you have done so already, all right, you will see that this arc, right, will make one intersection point here. One intersection point here. And the second intersection point here, right? Right. So we're going to go back to your compass, place it at the first intersection point, and draw another arc. All right. Then move your compass to the second intersection point, draw another arc. All right. So you see that these two arcs will intersect each other, right? Yes. So the next thing is that use the ruler again and the pencil, draw a line segment that will cut through this intersection point. Okay, and we're going to measure the angle now and see if you get 40 each. Oh yes, can you see that? Let me make it bigger for you. Yeah, so you can see that the angle ABC is clearly 80, right? Then from this part here, half of it from here, half of it is the below half, the 40, and above half is also 40. Okay, right. So therefore, this line here, okay, it's called the angle bisector. All right, so basically it just bisect your angle into two equal half, 40 and also 40 here. All right, so that's how you do an angle bisector. Okay, so with all these three basic concepts, now we are ready to do an O-level questions, right? So if you look at this O-level questions, we are given a triangle ABC is drawn for you. You're supposed to measure angle ABC. So that is pretty easy. You just use your compass to measure it. So we are not going to do part A. So part B, we need to draw a point D such that this is below the line AC. The point AD is 12 centimeter and CD is 9 centimeter. So at the next slide, I will show you how we do the constructions. Okay, then the next thing is that we will need to find a certain region. The region is called S, and this region S lies inside this quadrilateral ABCD, such that it has to satisfy three conditions. The first condition is that it has to be nearer to C than A. All right, so C and A are 2 points. Okay, So when you say it has to be nearer to C than A, what we are saying is that we need to find the perpendicular bisector of the line segment AC. Right? Recall the earlier 3 slides that we've done, the 3 basic concepts. If you're equal distance from point A and point B means you can be anywhere on the perpendicular bisector of the line segment, right? And perpendicular bisector, sometimes it can be rephrased, okay, in the exam questions or whatever. It can be rephrased such that you are equal distance, right, from point C and A, okay, as what we also have explained in the earlier slides. This region S must be more than 8 cm from B. So if you're at a certain distance from a certain point, then it means that we need to draw a circle, right, with radius 8 cm and center B. And the third concept, remember, if you are equal distance from 2 different line segments, okay, 2 different line segments, then we are referring to having to draw the angle bisector. Okay, so these are the 4 things that we need to do. We need to construct point D. We need to construct the perpendicular bisector of the line segment AC. We need to draw a circle with center B at 8 cm. And we need to draw the angle bisector of ABC. All right, so let's do it at the next slide. Okay, so we need to construct a point D such that the distance AD is 12 cm and then the distance CD is 9 cm. So you can use your compass to measure 12 cm and then place the sharp point of your compass at point A and then you make an arc. Next, you change the length of your compass to 9 cm, place it at point C and then make an arc. Right, and then you will use a ruler to join a line segment from, okay, let's label the point D first. And then join a line segment using a ruler and of course a pencil from A to D and C to D. All right, so this is the quadrilateral, the region ABCD. So we are told that there's a region S such that this region S must satisfy 3 conditions. So the first condition is that it has to be nearer to point C than point A. So from the earlier slides, we understand that that means if we say it's nearer to point A or nearer to point C, that means first of all we have to find the perpendicular bisector of the line segment AC. Right. Okay, and the second condition, it says that this region S is such that it is more than 8 cm from point B. So if you are at a certain distance from a certain point, the earlier slides that we have understood it's that we need to draw a circle. All right, in this case here is a circle with center B and radius 8 cm. Then the last condition, it says that this region has to be nearer to the line segment BA than to the line segment BC. And we also have understood that it means we have to find the angle bisector of this angle ABC. All right, so with all these conditions fixed, now let's go on to find the region that is required. Right, so it says that it has to be nearer to point C than point A. So basically, this is the region that it can lie, satisfying the first condition. Second condition is that it must be more than 8 cm, meaning it is outside your circle, anywhere there. The last condition, it says that it has to be nearer to the line segment BA. So using your angle bisector, all right, it has to be on the left side of your angle bisector. Okay, so that will be the required region. So that region will be where your S can be. Right, let's do another questions. This one here, I'm able to use the online interactive tools to show you how to do the perpendicular bisectors, and also to find the positions of the town D. Okay, but here, what I'm going to show you is to know how to do part 3. That is to find the scale. All right. So we have town ABC. A is due north of B. This is a piece of important information. C is due west of B. Right. So if you were to look at the 4 different the directions, the north, south, east, west, you will see that these 2 lines actually will intersect each other at 90 degrees. So therefore, in the questions, we're told that A is due north of B and C is due west of B. So that actually makes angle ABC 90 degrees. Okay, so angle ABC is 90. All right, so we're going to do part 3. So part 3, it says that the actual distance of AB is 48 kilometer. So by measuring the scale drawing, find its scale. So when you say by measuring the scale drawing, it's that I've given you the hard copy, right? So on the hard copy, you'll be given the questions. So you can actually use a ruler to measure the distance AB in centimeter. All right, so that will be the measurement on the map. So we have a measurement on map. We also have an actual one, right? So if we measure it correctly, if I'm not wrong, the distance AB is 6 centimeter. So on the map, it represents 6 centimeter, and actual distance is 48 kilometer. So what we are saying is that on the map, 1 centimeter will actually represent 8 kilometer in real life. Okay, so the scale is 1 centimeter to represent 8 kilometer. So this is the scale. All right. So for part 4, okay, for part 4, after you have done all the constructions, the perpendicular bisectors, and after you've found the locations M, and if you have done it quite accurately, the distance from D to M on the map, on your hard copy, right, will come up to be 8 kilometer, sorry, 8 centimeter. So if you convert 8 centimeter using the scale, so the actual distance will be 8 times 8, 64 kilometer in real life. So let's write it properly, right? So the actual distance will be 8 times 8, that gives you 64 kilometer. Okay, right, so the next slide will show you how we can find town D and also the positions for the mast M. Alright, so let's construct the 3 points first. So we are told that we have point C that it's due west of point B. Right, so your point C will be here. So this point C is due west of point B. And then we have town A, alright, which is due north of town B. So that makes the angle 90 degrees. Okay, so 90 is here. Alright, so we're going to join this Alright, so that will be your tau A. So therefore, the angle ABC will have to be 90 degrees, right? Because C is due west of B and A is due north of B. So that makes angle ABC 90 degrees. Okay, we have a fourth tau that is tau D. Tau D is such that angle BCD is 80 degrees. So we need to construct an angle that is 80 degrees. BCD is 80 degrees. Okay, so 80 degrees will be BCD. It's, oops, I think I put my protractor wrongly. 80 degrees, so 0, 10. So 80 is here. Okay, I need to draw it longer. So 80 degrees is here. Alright. And so I will draw a line segment that passes through that point. Okay, try to draw it as long as possible because this line segment is going to intersect line segment AD. Okay, and we also told the angle BAD is 110, right? 110. So we need to measure 110. Put it here. Alright, so 110 will be here. That's 110. Okay, let's draw a line segment. Alright, so this point here will be your point D. Okay, right. Okay, so in the questions we are told that there's a mass that is equal distance from tau A, B, and C. Right, so we need to find the positions of the mass. So equal distance from tau A, B, C means I need to draw the perpendicular bisector of AB and also the perpendicular bisector of BC. Okay, so let's see what happened. So to draw perpendicular bisector, we will need to use our compass. And let's draw an arc. Bring it to the other side. Let's draw another arc. Okay, and then draw a line segment that passes through this intersection point. Let's make it as long as possible. Okay, and then the next thing is that draw the perpendicular bisector of the line segment BC. Okay, I need to make this bigger a bit. Maybe I change a different color. Then you can see clearer. Change to green. Okay, fix it. Let's draw an arc. Okay, bring it to the other side. Draw another arc. Okay, and then we're going to draw a line segment. All right, so when these two perpendicular lines meet each other, that will be your mass M. So apparently let's choose a different color. Let's choose a blue one. Yes, so this will be your point M here. Can you see the green line? The green line and your pink color line will meet here. So that is your let's draw again, never mind. Wait, I should use green color. Alright, so M it's here. Okay, that is your M. This point here. Alright, so that point is M. Okay, the next thing is that I need to find the distance from the distance between D and M. Okay, right, so we just need to join from D to M, right, and then measure the distance. All right, measure the distance because I'm showing it using online and my dimensions may not be the same when you actually do it on the hard copy, right? So it's quite pointless for me to measure my distance dm because you will not be accurate. But I've just shown you how you can actually do the constructions, and then if you will do it on a hard copy, you should be able to measure the distance dm correctly.